Welcome back. I'm Rob Lang and this is my game Clomper. You live inside a mechanical ladybird called a Clomper, which you control by making pipes to power machines with steam. The outside world is a hellscape, which you explore from inside the Clomper, gathering resources and completing quests. That sounds like fun. Go wishlist on Steam. Oh, I've changed some things in this one. First we're going to look at how I galance a Bame. I'm so tired. We're going to look at game balancing and how you do it, and the claw and the changes I've made to it. So yay! Progress! Right, let's jump in. So why do game balancing at all? That's a good question. Well, imagine you just started a new game of Clomper like I have here, and you start putting pipes down, and then you run out of scrap, and you don't have any resources to link anything up, to move or get any more resources. It's basic stuff, but you should have enough to at least move the Clomper around. Otherwise, it's a really difficult game to play. I mean, you could still play it, couldn't you? Go, ooh, I've laid 8 pipes. What fun. Larks. Or you could also make steam come out the end. That's the game, thank you very much. So it begs the question, how much scrap is enough scrap? And that's what balancing is about. One way of balancing is playtesting, a lot.
I see you haven't fixed this damn interface.
You start off with some numbers that are vaguely sensible, and then you just get people to play it. And to be honest, a lot of it needs to be play tested, but there is a step that you can take before you get to play testing that will shortcut some of that. So how do you go about game balancing then? Well, every game has a model. Now in Clomper's case, it is 2 things. There is the obvious one, which is the cost of the pipes. Here we can see the T pipe is 25, the bend is 15, and the unit is 5. We also have the amount of resources you get every time you pick up a bunch of scrap. So those are 2 things, and they need to be kept in balance. Because I could make all the pipes 1,000,000 scrap, and then each time you pick up scrap that could be 5 million. You keep making those numbers bigger and bigger and bigger until they don't fit on the screen and are very difficult to use. So you want to try and keep the numbers as small as you can while giving yourself enough resolution so you can balance them. So for your game, you need to work out what questions are important to play it. For Clomper, there are 4 really. The first question is, how much scrap do you need to get the Clomper moving? Next, you need to know how much more do you need to actually go and pick up scrap. And then how much scrap do you need to build a cool network like this one? And finally, how much time does that take? Because in the end, you want to know how much time a player is going to have to spend to get to something that's a bit cool like this. Or even cooler. I'm sure you could make a better network than me. I'm not actually very good at it. So what tools can I use to answer these questions? First up, I looked at machinations, which is great for modelling state, but I don't really have lots of state conversions in Clomper. I only have one, you turn scrap into pipes. Also, machinations doesn't have a concept of time, so I'd have to build that in as a variable, and that starts to feel like it's not quite the right tool for the job, and I would just be forcing it to do something it's not designed to do. Next, I looked at Google Sheets. Now, spreadsheets are something I use a lot for work, and I've done a lot of data modelling in them in the past, and they would be fine. You can go in, you can change your numbers, you can say I want this pipe to be this much instead, but the issue with Sheets is that it doesn't load JSON very well, and JSON is the data format that I use for the save files, and I was hoping to use those. So I parked it knowing that this would be my fallback if nothing else worked. I could of course do it all in Unity. It's not a terrible idea. I'm pretty good at C#. You can make a new scene, add a graphing package to it, reuse a lot of the engine code, and even get it running at the same time the game was so I could see the changes in real time. And there's a considerable cost to every change. You have to code it, build it, run it, check it, change it, code it, build it, run it, and that build loop is kind of slow for what I needed. So again, this was a fallback option, but I felt there was a better thing to do it with. This is Jupyter Lab. It's a free Python data science tool which allows you to write some code very quickly, run it and get some results all within the browser. Now I'm not going to show you how to set this up. There's wonderful tutorials. I'll link them all down in the description. Go check those out. I couldn't possibly do a better job than they have. However, I can show you what I've done for Clomper. To answer my questions, the very first thing I need is a list of pipes with what they cost. It's like a menu in a restaurant. I need to know what each one is going to cost me. And you can see this at the top of my Jupyter file. Now these costs you see here are ones I just made up for testing. I haven't really tuned them or thought too long and hard about them. I just thought, well, that'll do for a start. The next thing I need to do is get some save files with pipe layouts in them. So for this standard layout that I use for testing, the save file looks like this. You see you've got the boiler information at the top, how much scrap you start off with, and then a whole bunch of pipes with their positions and rotations, and if the valve's on and off. It's not very complicated, but really I just need a list of these code names really. In Jupyter Notebooks, the code is arranged in cells and it runs them in order. You can also run them out of order, but I've not needed to do that. The Python is pretty simple once you get used to it. I've split things up into functions, perhaps unnecessarily, but it makes it easier to read. The first function loads up a JSON save file and just creates a big old list of pipes. The next function takes that list of pipes, uses my cost model that we saw earlier, and then works out the total cost of all the pipes. The third function just joins those things together, and then at the bottom I'm calling the code and then writing it out. You see here I've got a big map, it uses the only cost model we have, and the cost is massive because there's loads and loads of pipes. That's all very well, but it's not that useful. This would take me a while to keep changing this. But this is Python and you can do looping. So what would it look like if I had a few cost models and a few different save files? Well, it's right here. In this notebook, I've got 3 cost models and I've each given them a name so I can tell them apart. The code is much the same, but there are loops instead. But now I've not only got more cost models, I've got a bunch of save files, and I can run the cost models against each one to work out for each cost model how much it would cost. If I wanted to make a new cost model, I can go to the top, add another one in, run all the code again, and it will give me the new values. And it's very fast to do that loop. If you've got a table of data, you can also plot it on a graph. Now on the graph, you can start seeing where I've gone a little bit wild. The x-axis are save files. The y-axis is cost. The size of the dots are how many pipes there are, and the colour is the model. Now you can see the ones on the right hand side is where I try to cram as many possible pipes into the Clomper in one go, which looks like this. Now for your own sanity, I wouldn't recommend building a pipe network like this, but it's good to have an outlier. What if a player did? What would that cost? And there you go. Now we know. So far we've looked at cost alone, but players don't really deal with cost, they deal with the time that they are spending playing your game. How much time does it take to build this simple map, periscope and legs? And then what does it take to go from there to a pretty nice layout like standard? Well, in my last video, you will have seen me attempting to play my own game and getting very frustrated with the claw, but we'll come back to that in a moment. So I added to my Jupyter notebook the time it takes to pick things up. If you're fast, 150 seconds, average play 300 seconds, and slow, which would be 480 seconds. This is now starting to get pretty large. So for my standard layout with the perceived usefulness model, if you were going fast, it would take you about 12 minutes, which is about right actually. If I come down here and see the standard, if you were going slow, it would take you about 40 minutes. Personally, I think that once you get into a bit of a rhythm, then you can go pretty fast. So you might start off slow, but you'll end up going pretty fast. So it would be somewhere between 12 and 38 minutes, which is about right. If I didn't like it, I could add another cost model, press play up here, and it will just calculate it all again. So I can try lots of different things and tweak stuff as I go. And this is important because the save files will change and the number of pipes will change. So things will change and I need to just be able to press go and then see what effect that will have on the amount of time. Let's just cut to a couple of weeks ago where I attempted to play my own game badly. I could do this as a reaction. What a good idea. Let's do this. Let's do this as a reaction. I'm amazed that anyone gets through my intro awake. It doesn't look like that anymore. I do miss the number of pipes that you had to use before I made these changes. That's true. Who's that handsome chap? So I've jumped forward to me struggling to use the claw. So this is the old way in which you would steer the claw, but there's lots of problems with it. If we pause here, you can see that there's no real way to tell where the claw is compared to the outside of the Clomper. That's a big problem. You can't see the legs, and the handle is really complicated. I've had problems with this since I put it in 2 or 3 years ago, but I've left it because it wasn't urgent to change it. But now it's definitely urgent to change it. I can't go to demo with this system, so I completely changed it. Let's see what I've done. At time of recording, I've not finished testing any of this. Okay, let's cheat some scrapping, because that's what I'm like. So beforehand, you had to power with Steam each of the separate directions, left and right and forward and backwards, and it wasn't immediately obvious in which way they went. Let's begin with the handle. It used to have 3 states: up, which it's in at the moment, down at the bottom, and also to the lift. I've removed the lift one because if a handle is up and the lift is down, that should be enough to move the scrap across. You don't need a 3rd state. It's not adding much. You'll notice when I drop the claw down that the camera doesn't move. So there we go, the claws come down, but the camera is still stuck to the Clomper. That makes it a lot easier to see what on earth is going on. You'll also notice there's a little flag now that tells you that there is a piece of scrap that's in the claw itself. Let's look at moving the claw now. So let's say you've got it not particularly well lined up. You can now use these wheels to move the claw around. So if I move the claw this way or this way, you can move it back and forth across. Now you can see how far you are. Not only that, now that can you see the legs. Thank you for everyone who pointed that out. That was very handy. But also you can see that the wheel is broken to show you're getting at the end. Also, there's a little arrow in there that tells you that you are in the middle, and it's the same for forward and backwards. So you know if you came up to the claw, if one of your friends had left the claw in a funny state, you would know that where the claw is in respect to left and right and front and back. Left and right isn't too bad because you can see the legs when you're clomping along, but front and back is quite important because if you have it all the way to the front or back, the scrap won't appear when you feel it will do, but it's quite easy to get it back in the middle now. And of course you can grab the scrap. Once the flag is up, it will bring it up with you and you can see what you've got in the claw because it's a nice ring. And then of course this still works. He says, I've not tested this yet. I'm still regression testing, so I've got no idea if this works. Let's see if it closes. It should close across there. That then disappears. That's nice. Oh, and it's magically appeared. Okay, so it's not completely working. Oh, it might be because I'll click the lift to bring it back up again. And then you can pick up the scrap and you can go and stick it in the grinder if I was close enough. That's something else I've got to sort out. We can stick it up and then you can bang it in the grinder and then that gives you more scrap. It's a bit ugly right now, but I'll come on to why that is in a moment. And also, I'm not a great fan of the fact that you don't really need that many pipes to get it sorted out. I think I'd prefer it as it was, where there was quite a lot of pipes to put in to get it moving, but I don't know. I think it's okay to have it quite simple because you need the lift. I can make other things more complicated, have stations which give you advanced kind of play styles and keep the claw nice and simple. Yeah, once again, thanks for all the feedback on the claw in the last playthrough. It was a really scruffy video, but I got brilliant comments off it. So far as I'm concerned, that's a massive win. So quick check-in on the roadmap. I'm here at the moment on the claw. I'm pretty much done with it. I'm just regression testing, which is a big old list of tests. I'll put a video down in the description on how I go about doing that. And once I've done that, the next thing to do is a graphics refresh, which I'm really excited for. I'm going to put new shaders in. There's going to be a whole bunch of new models. It's not going to look vastly different, but there's going to be a high level of detail and there's going to be the floor. And I can't wait to do the floor. It's going to be brilliant fun. I'm going to be modelling for hours. It's going to be great. I'm also up to 245 wish lists. Now I know you watch other game dev YouTube channels and they'll go, well, you need 7,000 to be a success. And yeah, well, that might be true for their particular form of success. But for me, 245 is great. It's going in an upwards direction and If you've not wishlisted, go and pop over, link down in the description, naturally. I do wonder if Clomper will get more downloads over its lifetime than my free tabletop role-playing game iCar. Probably not. I'm not going to wait until I've finished the graphics update before the next devlog. I'm going to keep pushing them out. It's going to take a while, and I think seeing the process is quite fun. Let me know if you think that's a good idea. If you don't show me the progress, just finish it and show me what happens. Thank you for coming along on this journey and your wonderful feedback. Don't forget to wishlist, and until next time, bye bye.